Hi guys, this is Vijay and I hope you are doing well. In this video lecture, we will derive the heat conduction equation for spherical coordinate system. First of all, what is the application of spherical coordinate? While dealing with the problem of conduction of heat through the system having spherical geometries like as a spherical tank, spherical vessel, nuclear reactor, any type of shape, which shape is sphere. So at that time it is convenient to use spherical coordinate system to solve the problem of heat transfer. This is the application of general heat conduction equation in spherical coordinate. In previous lecture we were derived the equation for cylindrical coordinate and Cartesian coordinate system. So for that, here we are considering point P in three-dimensional body, which coordinate is r, theta and phi, where r is the radius from the origin to the point P. Here theta, it is the angle measured from the positive z axis, and angle phi, it is measured from positive x axis in the direction of positive y axis. So to indicate the elements of a sphere in a three-dimensional body, here we require the three coordinate, two angle and one radius. So one angle is in the vertical plane, second angle is in horizontal plane, and r is the radius. So here you can see that this radius, it will make angle theta with z axis, and we know that which term which makes the angle with the reference line, this term is called cos term, and the remaining term is called sin term. So this radius, it will make the angle with positive z axis. So this component, whenever we resolve the component, so this is r cos theta and this is r sin theta. So which term which makes the angle with the reference line, this term is called cos term and the remaining term is called sin term. So this is r sin theta, so this is also r sin theta. Here we are considering small element of the sphere, and our objective is to calculate the dimension of this volume element of the sphere. So for that, here we are considering this small element of a sphere at radius r from the origin. We have already discussed r sin theta and r cos theta in this term, which terms makes an angle with the reference line. This term is called cos term and the remaining term is called sin term. This is r sin theta, this is also r sin theta. Here we have already discussed. Here angle phi, it is measured from the positive x axis in the direction of positive y axis, and this is d phi for the small element. This is the angle phi which is measured from positive x axis in the direction of positive y axis. So it is for d phi, this is the angle for small element, and this is the projection of this plane. Here you can see that, so this is d phi, so this is also d phi. And here we are considering the thickness of the volume element of sphere is dr. Now our objective is to calculate all dimension of the element. So for that, we know that according to the fundamental of mathematics, angle equal to arc divided by radius. So our objective is to calculate this dimension. This is a small arc which is unknown. So for that, here we are using fundamental of mathematics to calculate the unknown value arc. So angle equal to arc divided by radius. So arc equal to angle into radius. So here radius is r sin theta. We have already discussed how can we derive it r sin theta by resolving the component of radius. And this term it will makes the angle with the reference line. So this is r cos theta, this is r sin theta. So this is r sin theta, so this is also r sin theta. Here same, this is r sin theta, r sin theta. So the radius is r sin theta. So whenever we put the value in this equation, so arc equal to radius into angle. So arc equal to angle d phi into radius r sin theta. So this unknown value, or we can say unknown dimension, we can calculate by using fundamental of mathematics, angle equal to arc divided by radius. So this dimension is r sin theta into d phi. Same as here you can see that this angle is d theta. This is theta, so this is d theta for a small element. And we know that angle equal to arc divided by radius, and our objective is to calculate this unknown dimension for the small element. We know the thickness, so the 2 dimension is remaining. So here we are again using the fundamental of mathematics, angle equal to arc divided by radius. So this arc equal to angle into radius. So the radius is r and the angle is d theta. So this dimension is r d theta. So whenever we enlarge the volume in large scale, so here you can see that here the dimension is r d theta, dr, and r sin theta into d phi. Here we are considering the heat transfer in 3 direction, in direction of r, theta and phi. So q dash phi, it is the entry of heat, and q dash phi plus d phi, it is the exit of heat in 5 direction. Same as q dash r, or we can say del by del r, it is the heat transfer in r direction, and q dash r plus dr, it is the exit heat in r direction. Same as q dash theta, and q dash theta plus d theta, it is the heat transfer in theta direction. Now we will apply the energy balance equation for small volume element of sphere. According to the energy balance equation, the net heat accumulated in the element due to the conduction of heat from all coordinate direction considered plus heat generated within the element equal to energy stored in the element. So one by one we calculate the term A, B and C, and finally we will put the value of A, B and C in this equation. So finally we can solve the equation for spherical coordinate system. So let us try to understand what is net heat accumulated in the element due to the conduction of heat from all coordinate direction considered. For that, here we are considering a small element of sphere, and 200 joule it is the entry of heat, and 60 joule it is the exit of heat for this small volume element. So the net heat equal to 200 minus 60 equal to 140 joule. It means that some of the energy it will be stored in a body whenever there is a transfer of heat. It is called net heat accumulated in one direction. Same as we can calculate for 2 remaining dimension, and the sum of net heat accumulated in all 3 directions, theta, phi and r, it is called total heat accumulated in all coordinate direction considered. So I hope you can easily understand what is net heat accumulated in the element by considering this example. So here the volume of the element is dr, which is thickness of the element, r d theta, we have already discussed r d theta and r sin theta into d phi. We have already calculated this unknown dimension of the element by using fundamental of mathematics, angle equal to arc divided by radius, so arc equal to angle into radius. So here we are also considering internal heat generation. Internal heat generation means our objective is to calculate the universal equation which is applicable to all the cases. But in some of the cases there is an internal heat generation will be there. For example, in case of a electric motor, whenever the current will flow, so at that time it will generate the heat. It is called internal heat generation. Same like as in a nuclear reactor. So whenever the fission reaction it will be take place, so at that time it will generate the heat. It is called internal heat generation. So in many of the cases there is no any internal heat generation, so at that time we are not considering, but our objective is to derive the equation which is applicable for all cases. So here we are considering. Now we calculate net heat accumulated in the element term A. So here we are considering the direction one by one. The first direction we are considering phi direction, heat flow through the r theta plane. So according to the Fourier law for the conduction, so according to Fourier law, Q equal to minus K dt by dx, where K is the thermal conductivity, A is the area which is perpendicular to the direction of heat flow, and dt by dx which is temperature gradient. Remember guys, here we are considering area which is perpendicular to the direction of heat flow. So in all the three cases we are considering perpendicular area in the direction of heat flow. So first of all we are considering the direction is phi, or we can say r theta plane. So heat entry, or we can say heat influx in phi direction. So we compare with the Fourier law. Here we are using a negative sign because it is always flow from high to low, and it will be decreases with respect to thickness. So the heat transfer will be take place from higher to lower, and it is decreases with respect to thickness. So here we are considering negative sign. Here we are considering area which is perpendicular to the direction of heat flow. So our direction is Q dash phi, or we can say del by del phi. So the perpendicular area is r d theta into dr. Here you can see that this is perpendicular area, and thickness is r sin theta into d phi, dt by dx, where dt is the temperature difference and dx means in Fourier equation thickness. So our thickness is r sin theta into d phi whenever we compare with the Fourier law. So here we are considering it is a function of time, so d tau, we are considering d tau. It is called equation 1. Same for heat exit or heat efflux equal to Q dash phi plus d phi equal to Q dash phi plus del by r into sin theta into del phi into Q dash phi r sin theta into d phi. Okay, this equation we can also derive it by using Taylor series. Okay, we have already discussed in our previous theories of Cartesian coordinate and cylindrical coordinate. If you want to clear your fundamental how can we derive it, then you can watch it. So same as here you can calculate the heat accumulated in the element by subtracting equation 2 from equation 1. So here you can see that in equation 1 and equation 2 the common term is Q dash phi. So it is cancelled out. So the remaining term is the difference, or we can say net heat accumulated dQ dash phi equal to Q dash phi minus Q dash phi plus d phi. Here Q dash phi, it is the heat entry and this is heat exit in phi direction. So in equation 1 and equation 2 this term is common, so it is cancelled out. So the remaining term is this term, and due to the subtraction the negative sign will be there. So equal to minus 1 upon r sin theta into del by del phi Q dash phi into r sin theta into d phi. So this is the net heat accumulated in the element due to the heat flow in phi direction. Continue from previous slide. Here we will put the value of Q dash phi from equation 1. So from equation 1, here we will put the value of Q dash phi in this equation. So d Q dash phi equal to, here you can see that here we will put the value of Q dash phi from equation 1, and this is the simplified form of this equation. Here you can see that this is a minus sign, this is also minus, so minus minus plus. Here you can see that del by del 5, and here del t by del 5 is there. So whenever we multiply this term with this term, at that time it will become del square t by del 5 square, and this is the common term, and d term. So this is the heat accumulated in 5 direction, net heat accumulated in 5 direction. Same as the heat flow in R5 plane, or we can say in theta direction. So this is theta direction. Here you can see that q dash theta, or we can say del by del theta, it is the heat entry, and q dash theta plus d theta, it is heat exit in theta direction. So same as here we applied the Fourier law. According to the Fourier law, q equal to minus ka dt by dx. So the area we are considering perpendicular area. Means in Fourier law we are considering the area which is perpendicular to the direction of heat flow. So in this direction the area is, here you can see that this is perpendicular area, dr into r sin theta into d phi. Okay, this is the parallel line. We can consider r sin theta into d phi into dr. It is the perpendicular area in direction of heat flow in theta direction. And in dt by dx we are considering thickness is r d theta, and it is a function of time, so d term. Same as heat exit in theta direction equal to q dash theta plus del by r del theta into q dash theta into r d theta, which is called equation 4. So the heat accumulated in the element due to the heat flow in theta direction. So for that here we subtract the value of equation 4 from equation 3. We have already discussed in previous slide by considering the example. Okay. So in equation 3 and equation 4, the common term is q dash theta. So it is cancelled out. So the remaining term is, we continue from previous slide, and the common term is q dash theta. So the remaining term is it accumulated in r5 plane or theta direction equal to minus del by r del theta into q dash theta into r d theta. Here the negative sign, it is due to the subtraction of the value. Further, we will put the value of q dash theta from equation 3. From equation 3, we put the value of q dash theta in this equation. So here you can see that this is a negative sign. This is already negative sign will be there. So minus minus plus. So we will continue from previous slide. So minus minus plus. This is a common term. Dr into r d theta into r sin theta into d phi. Here 1 upon r is there. In bracket 1 upon r is there. So 1 upon r into 1 upon r square into 1 upon sin theta, and del by del theta into bracket sin theta into del t by del theta into d term. So this is the heat flow in theta direction. Same as heat flow in theta phi plane or in r direction. So again we applied the Fourier law, q equal to minus k dt by dx, and in r direction the area which is perpendicular to the direction of heat flow is this plane, and its dimension is r sin theta into d phi into r d theta and r sin theta into d phi. Put this value which is the perpendicular area in the direction of heat flow, and thickness we are considering dr. Thickness in all the cases we are considering parallel dimension, and area we are considering perpendicular dimension, and d term is already there because it is a function of time. Same as heat flux, heat exit, it is called equation 6. Now heat accumulated in the element due to the heat flow in r direction. So subtract the value of equation 6 from equation 5, and we are getting dq dash r equal to minus del by del r q dash r into dr. Here we will put the value of q dash r from equation 5. So from equation 5 we will put the value q dash r equal to minus k into bracket r d theta into r sin theta into d phi bracket complete del t by del r into d tau. Here you can see that this is the value of q dash r from equation 5, and already dr is there, and this is the simplification of this equation. Now our objective is to put the value of net heat accumulated, heat generated and heat stored in energy balance equation. So our objective is to first calculate total heat accumulated, or we can say net heat accumulated in the element. So one by one we have already derived net heat accumulated in 5 direction, or we can say in r theta plane, same as heat flow in r5 plane, or we can say theta direction, and heat accumulated in the element due to the heat flow in r direction. So in previous slide we have already derived this equation. So here you can see that in all the 3 equations the common term is k into dr into r d theta into r sin theta into d phi, and the sum of heat accumulated in all the direction, it is called total heat accumulated, or we can say net heat accumulated in the element. So here we keep out this term is common, and the remaining term is this, and d tau is also common. So this is the net heat accumulated in the element. So here we are considering r direction, theta direction and 5 direction, and the total heat accumulated, it is the sum of heat accumulated in r direction, theta direction and 5 direction. Now we have already discussed in some of the cases there is an internal heat generation. So here we are considering, so we know that small q equal to capital Q divided by V, where small q is a specific heat, this is the total heat divided by volume. So total heat equal to specific heat multiplied by volume, and here we are considering volume of the element is dr thickness into r d theta into r sin theta into d phi. This is the volume of the element. And energy stored in the element, the increase in thermal energy in the element is equal to, we have already discussed energy stored in the element, the general heat transfer equation mCp delta T, but we know that our objective is to convert the value of mass into volume, because in all the term the common term is volume. So we need to convert the mass into volume. So by using the fundamental property, mass equal to density into volume. So density equal to mass upon volume, or we can say mass equal to density into volume. So here we will put the value of volume equal to dr into r d theta into r sin theta into d phi. So now according to the energy balance equation, A plus B equal to C. So here we will put the value of A, B and C in energy balance equation, and we are getting this equation. So here you can see that in this equation the common term is k into dr into r d theta into r sin theta into d phi on both the sides. So it is cancelled out. In equation of A plus B equal to C, energy balance equation, this is a common term, so it is cancelled out. So dividing both sides by k into dr into r d theta into r sin theta into d phi into d tau, we get this equation. Okay, here k term is there, so divide by k, it is cancelled out. Here there is no any value of k, so rho c by k, here you can see that rho c by k into del t by del tau. Okay, and we know that k by rho c means alpha equal to thermal diffusivity, but here rho c by k is there, so it is 1 upon alpha. Okay, it is equal to 1 upon alpha. So this is the general heat conduction equation for spherical coordinate system. This is a general heat conduction equation for spherical coordinate. So in this equation, if there is no any internal heat source, or we can say there is no any internal heat generation is present, and the heat flow is steady and one direction, then equation is reduced to, so one dimension means theta and phi direction we are neglected. There is a transfer of heat in theta and phi, it is neglected because here we are considering only one direction. Steady state means this term it will become 0. Steady state del T by del tau is 0, and there is no any internal heat source, or we can say there is no any internal heat generation, so this term is also become 0. So the equation is reduced to 1 upon r square into d by dr into r square into dt by dr equal to 0. Thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also share with your friends. Thank you friends.